Delineation is defined as a device or combination of devices that provide regulation, guidance, and information to the driver. These devices include pavement markings, highway signing, and post-mounted delineators. The question is no longer whether or not delineation is effective, but rather how to provide the highest quality, year-round delineation system. While roadway delineation represents several devices, application of pavement markings offers one of the highest cost benefits to the motorist. It is the goal of the Federal Highway Administration to have adequate roadway delineation and markings on all major roads at all times. The objective of this videotape is to assist highway agencies in developing a field inspection program to evaluate roadway delineation systems throughout the life of the markings. The major emphasis will be placed on pavement markings. Field inspection is necessary to ensure that marking materials are applied or removed in accordance with the project specifications to produce immediate and long-term effectiveness. It is important to note that poor application of quality material will result in substandard delineation. Part 1 of this tape will cover inspection points, which are important to pre-application of materials, application of markings, and inspection of new markings. Part 2 of the tape covers application of other delineation, maintenance, and inspection, and presents a review of the material presented. Pre-application procedures and policies have a large influence on the performance of pavement markings. Major concerns are material acceptability, pre-markings, clean dry pavements, and temperatures of ambient air, pavement surface, and materials. First, all pavement marking material used should be approved by the state's laboratory or regional center prior to application on the job. Laboratory tests are made on material, binders, glass beads, sealer, primers, adhesives, raised pavement markers, and sign materials. Pavement marking materials are usually furnished from a pre-qualified source in accordance with state highway agency specifications. The materials are tested at the factory, placed in sealed containers, and shipped ready for use. If contractors are used, they should be pre-qualified by your agency. Make sure the contractors use only approved materials and their equipment meets the requirements for doing the job. Samples of materials that are not pre-qualified should be submitted to the state's laboratory or regional center. As a general rule, 3 samples per batch are taken for analysis. It may be necessary to pre-mark the pavement surface before applying a new traffic stripe. Pre-markings help striping machine drivers and spray gun operators to neatly apply required roadway markings. Pre-markings for new roads or pavements must be applied to identify all center lines, lane lines, edge lines, no passing lines, stop lines, and etc. The customary method of pre-marking utilizes narrow pilot lines or dots spaced about 5 feet apart. Pre-markings for new seal coat surfaces generally involve placement of flexible markers at intervals along existing markings prior to the seal coating application. The seal coat material generally will not obliterate the flexible markers. Pavement marking materials should not be applied to dirty pavement surfaces. Laboratory tests have indicated that cleaning the surface of dirt, sand, grit, gravel, and other foreign materials prior to application substantially improves adhesion. New Portland cement concrete pavements generally have a film of curing compound on the pavement surface. This film must be removed prior to application of the marking materials. The width of removal should be the width of the markings plus 1 or 2 inches. The techniques that could be used for cleaning the pavement include hand brooming, sweeping, and air blasting. Generally, for restriping operations, the traffic will remove most of the foreign materials from the pavement. However, problem areas may need additional cleaning. Air blasting from the striping machine's air compressors generally remove most foreign materials. Where asphaltic or chip seal materials are applied to the surface, mechanical sweeping may be necessary prior to applying pavement markings. Intersections and other areas, such as traffic islands, may require hand brooming to remove wind-blown sand and gravel. In addition to being clean, the road surface must be dry prior to applying most pavement marking materials. Markings placed on wet pavements generally will fail after application. There are several test methods to check for moisture in the pavement. A visual examination should be made of the road surface to be marked, especially after occurrence of rain, fog, or dew. Pavements in high humidity areas and in low-lying wet areas should be examined closely for wet surfaces. Aluminum foil or roofing paper may be used to test for wet pavement. Simply tape the foil or paper to the pavement and apply marking material on the foil. Clear plastic food wrap may also be used. Tape the plastic wrap to the pavement and wait 15 minutes. If moisture appears beneath the plastic, the pavement is too wet to mark. Litmus paper placed on the pavement under pressure for about 5 minutes will test for moisture as well. If the paper changes color, the pavement is too wet to mark. Pavement marking materials must be applied at optimum temperatures in order to obtain excellent results. The temperatures of the ambient air and pavement need to be taken only during the morning, unless unusual weather conditions exist. For most materials, the ambient air should be above 50 degrees. Use a road surface thermometer to ensure that the pavement temperature is above the highway agency's or manufacturer's recommended temperature. Applying marking material when the pavement is too cold could cause a poor bond. Temperature measurements of the marking materials require more attention. Any variance from the manufacturer's recommended temperature range could adversely affect performance of the markings or the warranty of the materials. For example, thermoplastic should be 425 to 435 degrees Fahrenheit. Temperature checks of heated materials should be made throughout the project. Applying material when it's too cold results in poor bonding with the pavement. Temperatures that are too high may scorch the materials, causing discoloration or brittleness. To ensure proper heating, check all material temperature gauges daily against a calibrated thermometer for accuracy. Measurements should be taken every 2 hours or less. Record ambient air, pavement surface, and marking material temperatures at the time of application and store in the project files. Another concern is the application of material. Pavement marking materials are divided into several classifications according to their formulations and applications. The decision to use a specific material should be based on individual state policy. Application requirements and quality control techniques generally vary from one type of material to another. Some items to watch for include correct machines for the job, protection of workers and wet markings, uniform distribution and quantity of materials, straight and even lines with sharply defined edges, and drying time of marking materials. In addition, there are other items to be considered for each type of marking material. Nighttime delineation is one of the highest benefit cost safety improvements that can be made on a street or highway. Pavement markings visible in the day will not be visible at night unless they are retroreflective. Retroreflection, or brightness, is obtained by the use of glass traffic beads added to or mixed with the marking materials. Glass beads also increase the durability and skid resistance of markings. Traffic paints are the most commonly used marking material. However, other materials are experiencing increased usage because of their durability. Today, painted markings are used alone or in combination with other marking devices. Newly applied traffic paints should be inspected for no track times and uniform distribution of drop-on glass beads. Thermoplastic markings are a cost-effective alternative to conventional paint marking when durability is a critical factor. All thermoplastic materials placed on concrete pavements and concrete-like aged asphaltic pavements should have a primer coat. The primer coat should be tacky dry to the touch, similar to adhesive tape, before applying the material. Also check newly applied thermoplastic materials for air bubbles. If air bubbles appear on the surface of the material, the pavement is too wet and the job should be shut down until the pavement dries. Polyester and epoxy are two additional types of markings. Polyester has been used with success in northern states. Both are durable but have special application requirements. The high temperatures necessary to achieve a molten state for thermoplastic and epoxy application requires expensive installation equipment and experienced operators. Cold plastic striping materials, such as preformed plastic tape, eliminates this requirement, needs no hardening time, and under certain circumstances, exhibits a high level of durability. Preformed cold plastic markings can be installed by the inlay or overlay method and can be ready to receive traffic immediately after installation. These markings should only be used where adequate illumination is provided on the road or street. The inlay method is used with new construction or resurfacing of asphalt concrete surfaces. While the asphalt is still warm, about 140 degrees, the pressure-sensitive, self-bonding tape is rolled into the surface of the pavement. Priming of the pavement is not necessary. The overlay method is employed on existing older pavements. Better bond is achieved when primer is applied prior to the installation. Manufacturers may recommend 2 coats of primer on the pavement and 1 coat on the film, particularly for intersection markings with heavy turning movements. Preformed plastic materials and tapes also are used as temporary markings in construction work zones. The use of glass beads embedded in traffic paint resulted in a breakthrough in providing low-cost nighttime retroreflective stripes. Unfortunately, these stripes are not too visible when they are needed most, at night, when the roadway becomes wet. One solution to this problem is the use of raised or recessed markers to supplement painted markings. Raised pavement markers are placed above the pavement surface, while recessed markers are placed in grooves or cuts in the pavement. This portion of the highway surface should be free of dirt, curing compound, grease, oil, moisture, paint, and any other foreign materials which could adversely affect the bond adhesion of the marker. An adhesive should be applied to each marker or to the pavement. The marker should then be applied to the pavement immediately after applying the adhesive. Care should be taken such that the correct amount of adhesive is applied to the marker or pavement. The marker must be protected against traffic impact until the adhesive is hardened. Adhesives can cause severe inflammation of the skin. Crews should use gloves and protective cream to prevent contact with the adhesive. The color of the markers match the color of the stripes they supplement or replace. Spacing of these markers should be in accordance with the Manual on Uniform Traffic Control Devices Standards, or MUTCD. Daily measurement of film thickness should be taken for project records. Thickness measurements of applied markings generally are made without drop-on beads, while the film is still wet. This is done on test plates placed in front of the striping machine, moving at normal striping speed. The test should be made quickly after application, using a wet film thickness gauge before the materials begin to dry. Measurements of some materials are made when the film is dry because the material may be composed of mostly solid ingredients, or because the materials may have a very short drying time. Thickness measurements may be made with or without drop-on glass beads. Dry film thickness may be determined in a similar manner by placing a test plate or strip of duct tape in front of the striper and using a measuring gauge to determine the actual thickness. For accurate results, take several readings at selected locations throughout the project. Here are some recommended thicknesses for paint and thermoplastic. Other thicknesses should be as recommended by your department or the manufacturer. Or refer to the Pavement Marking Inspection Training course published by the Federal Highway Administration. Measurements should be taken randomly on level sections of the highway. The measured thicknesses of the materials should be recorded on the appropriate form and placed in the project file. Drop-on beads should be tested in the field for the quantity applied. Compare the actual rate to the specified rate and adjust guns accordingly. The type and amount of glass beads also depend on the marking material and may vary somewhat from state to state. Nominal amounts for paint and thermoplastic used nationwide are as follows. When inspecting new markings, first try to get an overall impression. Look closely at the quality of the markings and the project samples. The geometry, coverage, workmanship, and tracking should be viewed at a distance of 10 feet or more. The application should closely follow pre-marking. Ideally, the stripes should be rectangular, and the edges should be crisp and well-defined. Tolerances for line widths and alignment vary from state to state. Here are some recommendations. Width, 1/2 inch over, 0 to 1/8 inch under. Length, 10 feet plus or minus 1 foot. Gap, 30 feet plus or minus 1 foot. Alignment, 1 inch deviation on tangents and flat 1 degree curves. Sharper curves of more than 1 degree permit 2 inches of deviation. The amount and gradation of glass beads used in different types of materials may vary somewhat from state to state and according to the type of material used. Inspection of glass bead distribution may be made visually. The drop-on beads should be uniformly distributed over the entire surface of the material and embedded to a depth about 60% of the diameters. Use the sunlight shadow technique, a pocket microscope, or a portable retroreflectometer for making daytime tests. The sunlight shadow technique may be used when the sun is from 20 to 80 degrees above the horizon. View the markings along a plane parallel to your shadow. As your shadow touches the marking, look for conditions that indicate excellent bead application and nighttime visibility. The stripe should give a smooth, uniform retroreflectance that makes the entire surface of the stripe appear to glow. Reverse positions and the stripe surface should appear dull and grayish in color. If alternating bright, dim, or non-retroreflective areas are apparent across the stripe, further evaluations may be needed. An inexpensive lighted microscope is used to assess the density, distribution, and embedment of the drop-on beads immediately after application of the material. The material should be dry and free of loose particles. If additional evaluations are needed, a portable retroreflectometer can be used to measure nighttime visibility of pavement markings. Measurements are made during the daytime on clean, dry markings. Some important things to remember. Zero the instrument after it warms up. Check required air temperature ranges. Avoid direct sunlight. Select level marking sites. Record a number of measurements at each site and average the readings. Different retroreflectometers are commercially available for purchase and use. The markings should have a minimum initial and maintained coefficient of retroreflected luminance of about 150 units for white and 100 units for yellow. A unit is 1 millicandela per lux per square meter. Project and yearly averages of applied materials should be calculated and compared to specified or expected values. The volume of materials is calculated as follows. Thickness may also be calculated by measuring the quantities of materials used and calculating the actual thickness by using equations. Part 2 of the tape covers application of other delineation, maintenance, and inspection, and presents a review of the material presented. Now is the time to stop the tape and discuss what you've seen. Markings alone may not provide the delineation needed to safely drive highway sections with curves or obstructions. Delineators, warning signs, and object markers, all described in the MUTCD, are used to supplement markings. Delineators have gained wide acceptance as a roadside treatment. They are required on interstate highway ramps, speed change lanes, and on tangent sections of the through lanes where raised pavement markers are not used. The color of the delineators shall conform to the color of the edge lines as stipulated in the MUTCD. Delineators are usually mounted about 4 feet above the near pavement edge and should be installed from 2 to 8 feet outside the outer edge of the shoulder. Post-mounted delineators should be spaced 200 to 528 feet on tangent sections. Be sure any damaged or missing post-mounted delineators are promptly replaced. While lane closure may not be required in all cases, protection of the workers is achieved by use of signing and strategic placement of work vehicles. Warning signs supplement standard delineation when it is necessary to warn traffic of potentially hazardous conditions, such as a change in horizontal alignment. Warning signs require the driver's caution. They may call for reduction of speed or other maneuver that enhances safety for the driver, other motorists, and pedestrians. Warning signs such as the turn sign, curve sign, reverse turn sign, reverse curve sign, and winding road sign are known as the alignment series. These often have an advisory speed plate attached to show the maximum recommended speed around a curve or through a location requiring additional caution. Mounting height depends upon whether the sign is along a rural highway, urban street, or a freeway or expressway. Signs erected at the side of the road on rural highways are mounted a minimum of 5 feet, 7 feet preferred, above the edge of the pavement as measured from the bottom of the sign. Along urban streets where parking and pedestrian movements occur, or where there are obstructions to view, the mounting height is at least 7 feet. Along freeways and expressways, mounting height is a minimum of 6 feet, 7 feet preferred. An advisory speed plate is mounted on the same assembly with a warning sign and is at least 4 feet, 6 feet preferred, above the edge of the pavement. A large arrow sign or chevron alignment signs are used to give notice of a sharp change of alignment and are often used in conjunction with warning signs. Since warning signs are primarily for the benefit of the driver who is unacquainted with the road, it is important that care be given to the placement of such signs. Alignment of warning signs should provide 3 seconds of time for the driver to perceive and identify the road conditions, then decide on and perform any necessary maneuver. The turn sign is intended for use where engineering investigations of roadway, geometric, and operating conditions show the recommended speed on a turn to be 30 miles per hour or less. And this recommended speed is equal to or less than the established speed limit. The curve sign may be used where the recommended speed on the curve is greater than 30 miles per hour and equal to or less than the established speed limit. The advisory speed plate is intended for use to supplement warning signs. The minimum size of the advisory speed plate is 18 by 18 inches. The plate carries the advisory speed message in black on a yellow background and is incremented with multiples of 5 miles per hour. The plate may not be used in conjunction with any sign other than a warning sign, nor shall it be used alone. Whether a particular curve needs to be signed is based on the speed at which the curve may be safely traversed. This safe speed may be determined by any of 3 methods described in the Roadway Delineation Practices Handbook. These methods include determining the safe speed from a graph using the curve radius and super elevation rate, by calculating an equation using the curve radius, super elevation rate, and the friction factor, or the traditional method of a series of test runs using a ball bank indicator. There is also an electronic data acquisition system that replaces the ball bank indicator to determine safe curve speed. The device is operated by the test vehicle driver and records horizontal cross slope, distance, and vehicle speed in 1-second increments. Once the safe speed of a curb is determined, the spacing of the warning signs in advance of the beginning of the curb can be determined from this table, also presented in the handbook and MUT-CD. Where a turn sign is warranted, a large arrow sign may be used. The large arrow sign is a horizontal rectangle with a standard size of 48 by 24 inches. It has a yellow background with the arrow symbol in black. The large arrow sign shall be erected on the outside of a curve at right angles to approaching traffic and should be visible for at least 500 feet. Trial runs by day and night are desirable to determine final positioning. The chevron alignment sign is a vertical rectangle with a minimum size of 12 by 18 inches. It also has a yellow background with chevron symbol in black. Chevron alignment signs are erected at the outside of a curve, sharp turn, or on the far side of an intersection, in line with and at right angles to approaching traffic. Spacing of the signs should be such that the driver always has two signs in view until the change in alignment eliminates the need for the signs. To be effective, chevron alignment signs should be visible for at least 500 feet. Trial runs by day and night are desirable to determine final positioning. Over time, all signs will experience diminishing retroreflectivity or brightness level. The deterioration is a result of the sun's rays, moisture, pollutants, and even chemical reactions between the sheeting and the substrate. Loss of retroreflectivity can occur to warning signs from gunshots, spray paints, and vehicle impacts. Inspection for loss of retroreflectivity may be a simple visual inspection or inspection with a sophisticated instrument. The most simple method is to drive at night and look for obviously deficient retroreflection. An experienced inspector can determine when a sign is ineffective. If night inspection is not feasible, a daytime procedure may be employed. This procedure involves use of a 200,000 candle power beam directed towards the sign as the vehicle drives along the road. The handheld beam, powered by the vehicle's battery, is flickered across the sign by the driver or passenger. With a little training, the inspector can detect obviously inferior and failing signs. The most accurate method is to use a retroreflectometer to measure the sign's retroreflectivity in the field. The procedure is time-consuming and should be limited to questionable signs detected by a visual inspection or for those signs identified for possible replacement by a sign inventory. Object markers are used to mark obstructions within or adjacent to the roadway. Obstructions within the roadway are marked with Type 1 or Type 3 object markers. Objects not actually in the roadway that may be so close to the edge of the road that they need a marker are marked with a Type 2 or Type 3 object marker. Maintenance and inspection of pavement marking projects are necessary to determine the quality of the materials applied, the workmanship of the marking personnel, and are necessary to periodically evaluate marking policy. Day and night inspections should be made on roadway markings and delineation every 6 months or at least annually. Daytime inspections should include evaluation of the durability of the marking materials, color durability, skid resistance, and daytime visibility. Material durability is evaluated by measuring the percent of material remaining on a stripe compared to the percent of material of the initial stripe. The percent of material remaining may be considered the durability rating. Visually, compare the color of the yellow marking to the Federal Highway Administration Color Tolerance Chart, PR number 1 Standard Highway Yellow. White markings should have only slight yellowing. Measure skid resistance in SRT units using a portable pendulum-type skid resistance tester. Check daytime visibility of the markings by visual inspection. If necessary, measure the luminance factor using a tri-stimulus colorimeter. Recommended factors for asphaltic pavements are as follows: white, 30, yellow, 20, and for concrete pavements, white 40, yellow 30. The measurements should be taken on clean, dry markings. Visual evaluation of retroreflectivity can be made during the daytime by using the sunlight shadow technique as described earlier. Nighttime inspections are one of the best ways to check the retroreflectivity and the overall marking performance. Drive the entire project at night and look closely at the markings. The markings should exhibit excellent retroreflection. For the entire distance, the vehicle headlights illuminate the roadway, using both low and high beam headlights. If necessary, measure the nighttime visibility of the markings using a retroreflectometer as described earlier. A mobile laser retroreflectometer is being developed to evaluate markings while traveling at highway speeds during the daylight. It mounts on the side of a pickup truck and is used for determining the coefficient of retroreflected luminance. It is self-contained with a DC supply and is enclosed, so measurements can even be made under wet conditions. Once the mobile retroreflectometer becomes available, it can be substituted for nighttime inspections. Now let's review what we've learned. Roadway delineation materials should come from a pre-qualified source, or samples of the materials should be supplied to the state's lab for testing. Make sure that the pavement surfaces have been cleaned and pre-marked before applying new pavement markings. Visually test the pavement for moisture, or by using the aluminum foil, roofing paper, clear plastic wrap, or litmus paper tests prior to applying the materials. Make sure the ambient air, road surface, and material temperatures are within the highway agency's or manufacturer's recommended range. Any variance could cause a poor bond to the pavement. All temperatures should be taken at the time of installation, and the recordings kept in the project files. Application requirements vary among materials. Be sure to watch for correct equipment for applying the materials, protecting the workers, and wet marking, distribution and quantity of material, straight and defined lines, and drying time. The thickness of the material may be determined using a wet film thickness gauge. Daily measurements of material thickness and drop-on beads should be taken and kept in the project files. When inspecting new markings, first get an overall impression of the marking quality. Line widths and alignment should be in accordance with state or local specifications. Inspect the distribution of glass beads using either the sunlight shadow technique, the pocket microscope, or a portable retroreflectometer. Maintenance inspections of the markings should be made every 6 months, or at a minimum once a year. Inspections should include color durability, material durability, skid resistance, daytime visibility, and nighttime retroreflectivity. Note that lack of adequate retroreflectivity appears in the results of NCHRP report number 4-16 to be the major reason that drivers say that markings are no longer adequate for guidance. Drivers rely on pavement markings, post-mounted delineators, and signs to guide them safely on our nation's highways and streets. Through good quality control, workmanship, and day and night inspections, quality year-round markings can be applied and be maintained nationwide. Such markings provide a greater benefit to the public than any other roadway treatment.